Hello and welcome to the channel. Now, I know it's been a while, but trust me, I have been extremely busy. However, I wanted to make a video today. I have been also sick in the last few days, so I wanted to make this video. It's like kind of a tutorial in which I show you how you can measure DNA bands size on an electrophoresis gel using the ImageJ software. It's not going to be a tutorial per se, rather it's going to be me showing you how I do it. So if you do find any of this useful, I would highly appreciate, a like and a subscribe. And if you find anything incorrect in what I'm saying and you need that you should add something, please post it into the comments below. So without further ado, let's get into the video itself. Now, in order to estimate the fragment size using ImageJ, first of all, of course, I will need to download ImageJ. I already did that. Going to need to open it and open the image that I want to analyze. Let me do that. So this is an image of a DNA electrophoresis gel, right? So this basically is the product of an restriction digest with an enzyme of some plasmids. But of course, you can also do this to estimate the relative migration of, for example, protein masses in protein gels. But for right now, this is what interests me. So this is the ladder here in the image, and of course you can see the corresponding ladder here in the right. So this is the NEB 1KB plus ladder. Okay, so first of all, in order to work with this image, what I will do is basically modify it a bit. As you can see, this is both in color and it's also a little bit tilted to the right. I need to make this image perfectly straight in order to work with it. So what I'm going to do, first of all, let's crop it. So to crop the image, I'm going to select the rectangle tool from here. Going to select the region of interest. Let's say, for example, this one. Going to go to image and then choose crop. Here we go. Now I need to straighten the image a bit. I'm going to do this by going to image, transform and rotate. As you can see right here, you have you have the option to choose grid lines and you have the option to preview, and this would be the angle. So let's say that I need the image to be totally straight. It seems pretty straight to me right now, but let's play a bit with it. Let's say, for example, the angle should be -1. Sorry about that. Maybe minus. What would you say? I think this is about right or not. Okay, let's say that this is the way to go. I would presume this is actually pretty straight right now. The next thing I'm going to do is just process the image a bit. Let's go to 8 bits. Let's go to enhance the contrast a bit. I just want to see the lanes better. So let's say that this would be good. Okay, so the pixel values has changed. No things. So the next thing I'm going to do is basically the following. Let me crop the image further, just a bit, rectangle tool. Let's see, I'm gonna crop it like this. I need to select the whole ladder, okay? Okay, so let's say I need to work with this image exactly. So the next thing I'm going to do is I'm going to open from Analyze Tools the ROA Manager. So this is the Region of Interest Manager. As you can see right here, I have the ladder with the corresponding band sizes. And of course, I'm going to put this to tell ImageJ from this image exactly what is the actual length of the fragments. Let me just show you how I would do that. So first of all, I would select the line tool. I would go here, top, and I would choose the Y value of 0. So as you can see right here where my mouse is, this is the Y value. I'm going to use 0 because I need the Y value to be absolutely the same. What I'm going to do right now is draw some lines for each lane in the ladder. So by holding Shift, at least what I'm going to do because I'm using a Macintosh, so I'm going to press Shift just to keep the line straight, and I'm going to draw a line from the Y value 0 to just the bottom of the lane right here. What I'm going to do next is go Add, and I can rename this for 100 KB. Okay, I can show all and show the labels. Now, next, of course, I'm going to do the same thing, but for the 200 base pair line. Again, I'm going to select the Y value 0, press Shift, and then go down until the bottom of the 200 base pair lanes. I'm going to add, rename it to 200 base pairs. I'm going to do the exact same thing with the 300 one. So again, select Y value of 0, press Shift, go to the 300 base pair one. Then add, and then rename 300. Keep in mind that you need to press and hold Shift in order to make the angles of the angle of these lines 90 degrees. So these have to be perfectly vertical to the horizontal lane here. Of course, I'm going to basically draw the lines in exactly the same way for each lane, for example, for 400, 500, 600, and so on. And I will draw different lines exactly the same, starting from 0, going down for these lanes also in these specific particular wells in the gel. Let me get back to you when I finish that. Okay, guys, so 2 days and 3 hours later, after I selected all the lines, let me show you what you can do with them. Is go to Analyze, Set Measurements, and I need to make sure right now that only the display label is selected. You do not need any of these things right here. I will show you what mean gray value does, for example, but in a future video when I will show you how you can do a densitometric analysis of a gel. But for right now, make sure that display label is checked right here, and then you would go to OK, Analyze, and you will go to Measure. I don't know why, but it does not measure them all. So you need to select and measure them one by one. So this is the first lane, going on the second. For Mac users, I'm going to press Command M as a shortcut, like in Command Measure. For Windows, probably is Control M. So I'm going to measure all of them right now. Maybe I'm doing this wrong, I do not know. I'm just showing you what I'm doing. Okay, so I'm gonna just measure the ladder and the samples right here. Now I can press Control A or Command A, and I can basically save this data into a CSV file. Boom, so this is done. Going to open the CSV file because I'm not going to need ImageJ for now. Let's just minimize this, and this will be the Excel file. I'm going to, of course, maximize the window right here. Let's make this table a little nicer, maybe. Let's pick a nice font for it. Okay, what I'm going to do now, remember, this is the angle. So that's why I told you to hold Shift when you select the lines from 0 to the corresponding line, just to make sure that the lines are perfectly perpendicular. So the angle is -90. What I'm going to do right now is select a new lane that I will call relative migration. Good. Relative migration to what? So as a control, or basically to normalize things, I'm going to pick this line. So the 100 base pairs line as a 0, as it were. So I'm just gonna go here and I'm going to equals this one divided by 1069, and this will be the 0 line with the actual value of 1. The same for the next. This one will equal this divided by 1069, and of course, sorry, I can autofill the data. Next, I'm going to need another lane. This will be the length of the fragments. I'm just going to introduce here the length of my fragments on the gel, so the known lengths based on the ladder. This will be 100, 200, 300. Just let me show if it's never mind. Just gonna do this manually. $900, 1,000. Yep. Yep. Of course, if you have a smaller ladder, this would be way easier. I'm just showing you how you can do this, right? And of course, the length here I am going to leave unchecked, because this is the thing we would need to calculate basically. Just let me center this a moment. Okay, now because the gel does not exactly migrate linearly, rather logarithmically, I would want to calculate the log 10 of this right here, of the length. So I would say equals log 10 of this. This would equal log 10 of this, and so on until here. Of course, you can do the same thing in Excel. I'm using numbers right now because, yeah, it comes free with, you know, with iOS. So yeah, let's. Good. So the next thing we're gonna have to do is select the relative migration from here, along with the log 10 scale from this, and what we're gonna do is basically we're going to do a calibration curve. We're gonna go to chart and select a scatter plot. Okay. Of course, you can do the exact same thing in Excel. Here I'm going to go to series, I would think. I would pick a trend line. Let's say it's linear, but maybe a polynomial one would fit much better. Yeah, not much of a difference. A logarithmic one. No, that does not fit at all. Maybe this will also work, but let's stick with linear for now. The next thing I'm going to do is show equations and show the R² value. Let me select this and make it bigger so we can see the formula. Not this big. Okay, so this is the R² value. I would say it's pretty decent. For the polynomial one is even better. Let's go with linear for now. And what I'm going to do right now is basically I'm going to plot these points using this formula. So the x value would be the relative migration. And I'm going to paste here this formula. So this I would say it's minus 2.1381 times x, which is this one right here. It would help if you also say equal, times x plus 4.2199. And of course, you're gonna do the same for this one. So it would equal minus 2.1381 times x, which this time will be this cell right here, plus 4.2199. You can autofill the data. Okay, and to convert the log into basically length, you would need to do like this, would equal 10 to the power of the log 10 right here. You can autofill right here. And what I would do right now is basically 0 decimals. Okay, so these will be the length of my fragments. As I told you, you could also use a polynomial curve right here. And for the polynomial curve, of course, you're going to use this formula right here, where x is the same x as before. So this has the R² value of 0.9901. and for the linear it's 0.98. So it's a pretty decent R² value. Okay, so this is what I would do to measure the length of the fragments on a gel. Let's see if we got this right a bit. Let's check ourselves maybe. So A1, this would be the A1 fragment. Okay, as you can see, yeah, it basically migrates at about 500 something, right? The other one, A2, 5, 6, 7, 700 something. This one, A3, about 3000. It says here 3403, and so on. Let's compare these ones. So B4 with A3. Let's see. B4 is this one with A3. Those should be this kind of the same length, and yeah, they basically are. Did I choose here also? Yeah, with C4. Yeah, 3466, 435, 3400. Yeah, so basically this would be how you could measure the size of the fragments on a gel. Of course, the better you put these lines here, the better would be for measurements. I would suggest just center those and be as consistent as possible. And of course, make sure that your picture is completely horizontal, so no skewing to the right or to the left.